Section 15.14. Finding an invertible matrix. To use a matrix for a Hill-style cipher, that matrix must be invertible. Invertible matrices are often difficult to find. If the number of invertible elements in the ring is I, and the total number of elements is R, then the probability that a random n by n matrix over that ring is invertible is brackets 1 over R to the power n. For the R8 ring, 1 over R is 2 over 8, which equals 1/4. This is in sharp contrast to matrices over the rational numbers or the real numbers, where every element except 0 has a multiplicative inverse, and therefore almost every matrix is invertible. If the matrices are small, you can usually find an invertible matrix by choosing the elements at random and then trying all possible values for the last element, or, at worst, the last 2 elements. By using the last 1 or 2 elements, you can reduce the matrix to the bottom 2 rows and not have to do a full reduction for each trial. I have chosen not to cover determinants in this book, since I don't know of any use for them in cryptography. However, for readers who are familiar with determinants, a matrix is invertible if the value of its determinant is an invertible element in the ring. In particular, a matrix over the integers is invertible only if its determinant is +1 or -1. When the desired matrix is larger, it may not be feasible to find an invertible matrix. Instead, you need to construct an invertible matrix. You begin by constructing a set of matrices of the desired size in 1 or 2 specific forms, triangular and block diagonal. Here are 4x4 examples of the 4 types of triangular matrices. An upper triangular matrix has non-zero entries only on or above the main diagonal, upper left to lower right. All other entries are 0. A lower triangular matrix has non-zero entries only on or below the main diagonal. All other entries are 0. An upper anti-triangular matrix has non-zero entries only on or above the anti-diagonal, lower left to upper right. All other entries are 0. A lower anti-triangular matrix has non-zero entries only on or below the anti-diagonal. All other entries are 0. A triangular matrix is invertible if all of the entries on the diagonal are invertible. An anti-triangular matrix is invertible if all of the entries on the anti-diagonal are invertible. The inverses of these matrices may be found easily using the techniques of section 15.1.1. For upper triangular and lower anti-triangular matrices, the reduction process of section 15.1.1 should be carried out from right to left. A general invertible matrix can be constructed from these triangular forms by multiplying them. This must be done prudently. The product of 2 upper triangular matrices will still be upper triangular, and the product of 2 lower triangular matrices will still be lower triangular. Anti-triangular matrices do not have this property. A sound course would be to construct one matrix of each of the 4 triangular types, and then form their product. If the triangular matrices are A, B, C, and D, and their inverses are A', B', C', and D', then the inverse of the product A, B, C, D is D', C', B', A'. In addition to triangular matrices, block diagonal matrices can be used to construct invertible matrices. Here is a 5x5 example of a block diagonal matrix. This matrix may be called type 2-3 because it consists of a 2x2 matrix and a 3x3 matrix arranged along the diagonal of the 5x5 matrix. When 2 block diagonal matrices of the same type are multiplied, the result is a block diagonal matrix of the same type. The advantage of using a block diagonal matrix is that you can find the inverses of each of the blocks separately. If you string these inverses along the diagonal, the result is the inverse of the entire matrix. It may not be feasible to find an invertible 16 by 16 matrix, but it is not too challenging to find 4 4x4 invertible matrices. You can expand your invertible block diagonal matrix to a full matrix by multiplying by block diagonal matrices of other types, or by some invertible triangular matrices. Go all out. Construct your invertible block diagonal matrix using the largest blocks that you can, and use 4 triangular matrices, one of each kind. Your final invertible matrix is the product of all 5 of these matrices.